Hey everyone, welcome to part 3 of tutorial 4. I try to keep these videos fairly short, so that's why I've split them up into 3 parts. However, abstract list functions is a very important topic to master, so I thought I would give some guidance on that. So that's the only topic for today, abstract list functions and some practice problems. The practice problems in parts 1, 2, and 3 are shorter than the typical practice problems at the end of a standalone tutorial because there are 3 sets of them. This video is going to be super short and hopefully super informative. It's a basic look at 4 of the key abstract list functions. We take a look at the definition, the contract, and an example. The first one is build list. Build list consumes a non-negative integer n and a procedure f. Interestingly enough, you can pass 0 to build list and it will build you the empty list regardless of f. Otherwise, it will produce a list containing the numbers 0 through n plus 1, but with f applied to all those numbers. In my example here, I have used 5 as my non-negative integer and lambda of x2 as my procedure. So this function, lambda x2, is going to take in anything, any x, and output 2 no matter what. In this case, you've seen that it produces lambda of 0 through lambda of 4, which are all 2. This is a way to produce a constant sequence should you ever need one. The next one is map. Map will consume a procedure and a list and apply that procedure to the list. In this example, my procedure is taking 10 and subtracting n, and my list is the numbers 1 through 9. As you can see, it will output the reversed list, not because it's reversing the list, but just due to the nature of this subtraction. The next one, fold-L, you can possibly tell is more important, maybe not more important. You will find yourself using it more frequently, so I've decided to give 2 examples. Fold-L consumes a procedure f that takes 2 inputs, an initial value, and a list. It applies f repeatedly to the result of the previous application of f and the car of the list, the first element of the list. What that means is that it will call the function on the first element of the list and the initial value. Then it will call the function again on the second element of the list and the output of that function. Then it will call the function again on the third element of the list and the output of the second application of f, and it'll keep going until the list is exhausted. In this example, my function is cons, my initial value is empty, and my list is the numbers 1 through 12. And this is a super compact way to reverse set of numbers, reverse a list, any list, doesn't have to be a set of numbers, using fold-L. My second example is a bit more numeric in nature. It is, my function is missing a lambda. There should be a lambda here. I'll add one in the slides. It should be a lambda of xy, and then you take the difference of the square of x and the square of y. My initial value is 0, and my beginning list is 1, 2, 3, and 4. In this case, we'll take 1 and subtract 0 squared, giving us 1. Then we'll take 2 squared and subtract 1 squared, which is 4 minus 1, so 3. Then we'll take 3 squared and subtract 3 squared, which is 0, and then 4 squared and subtract 0 squared, which is why we get 16. The last one is fold-R. It consumes a procedure f that accepts 2 inputs, an initial value, and a list, just like fold-L. It's very similar to fold-L, but it applies the function in the reverse order. The example is, if we do the same thing as our fold-L example with the cons, but with build list 12 and add 1, instead of reversing the list, it will just give us back the same list. Here are the practice problems. They are simply to write these in Racket by yourself and to apply the 30-minute rule. So don't look at your definitions of build list, map, fold-L, and fold-R when you're doing this. These are the parameters that they should take as input and the function names. 30 minutes after you've watched this video, test your memory to see that you can remember what these functions should do, what parameters they should consume, and see if you can make your own implementations. This link will bring you to the Racket reference page on lists. It's a good read. You will find it very helpful as a reference if you're ever wondering what kind of information a function would take in, what kind of information it could output, or anything else relating to a list function. That's the end of tutorial 4. Thanks for watching this 3-part series, this trilogy of Racket, and hopefully after you master this, you will enjoy Racket that much more. Thanks for watching.